Okay, 2.4, two variable inequalities. So this one, I'm going to start with a quick review, and I'm going to try to make this one faster than the last few, because I think we can do this one quicker. Okay, so quick review. Single variable expression, 4 plus x. We can't do anything with an expression except for simplify it or plug something in. Okay, remember no equal sign, no answer. Okay, a single variable equation would be 4 plus x equals 10. What are we doing here? We're seeking a value for x that's going to make the sentence true. In this case, x equals 6. Okay, that's what we did in jousting armadillos. That's what we did in jousting armadillos also. Now, inequality is the same as an equation. Oh, I didn't show the work, but I hope this is becoming second nature to you now. In an inequality, we had to do the same thing, but we had to remember a few things. We subtracted 7 on both sides. We were trying to come up with values for x that would make this true. Divide by -2, divide by -2. X is greater than, notice the sign change, -7. So any value greater than -7 makes that true. Well, let's think of something greater than -7. How about 1? Is 1 greater than -7? Yes. So x equals 1. If I put a 1 in here, I get -2 times 1. What is -2 times 1? -2. Plus 7, what's that? 5. Is 5 less than 21? Yes. So this is the correct answer. Okay, that's all a review. Now, this is still a review. Let's look at it a little bit further. A two variable expression. Okay, I've got an x and I've got a y. Okay, this is an expression, no equal sign, no answer. What can I do with it? I can only simplify it, which means combining the things that are alike. Those are alike. Those are alike. So 3x and 7x, 10x. 2y and -8y is -6y. That's all I can do. Nothing else. A two variable equation, it has an equal sign and an answer. All I can do here is what we've been doing in this chapter. X and y, I'm coming up with pairs that make this true. If x is 0, what does y have to be? Well, I put a 0 in and it has to be 20. So that's one solution. If I put a 1 in, I get 2 times 1 plus y equals 20. That gives me 2 plus y equals 20. So y has to be 18. So I get 118. So remember, I get sets of numbers that make that equation true. How many are there? Infinite, right? Infinite solutions. How do I show them? On a graph. Okay, so a two variable inequality is very similar to that. I've got an inequality, a greater than, I've got a y, I've got an x. What am I going to do? I'm going to have to do the same thing. Come up with pairs that will work and ultimately a graph that will satisfy it. Okay, I'm not going to do that one. I'm going to show you how to do that one. Okay, number 1, in this lesson, look back at the first question in this lesson. It says, look back at your note to self from 5.7 in Jousting Armadillos. Solve linear inequalities. What is the key difference between single variable equations and single variable inequalities? Okay, the key difference, and I'm telling you this, even though you really should look it up yourself. So maybe you did already and you're watching this after the fact. The key difference is that when you divide, and I just did it in the last problem, by a negative number, in an equation, nothing happens except for your calculation might change something. But when you divide by a negative in an inequality, what do? You switch the sign. And I told you, hopefully I did, and if I didn't, I should have. I should have told you to star this, to highlight it, to do everything you could to remember this fact. And you'll notice in the book he says it like 100 times, and that's because students and teachers and adults and people forget this all the time, and your answer is wrong unless you remember this minor but major fact. Okay, so when I'm going to solve, when I'm going to graph inequalities, I still want to get them in that y equals mx plus b format, slope-intercept format. We're only doing I believe, well, you might do a few, but most of your inequalities are going to be linear. So I want to make it y, and now it's not going to be an equal sign, but I want it to have a y by itself. So the first directions say, solve the following inequalities for y, keeping in mind the thing that you started and highlighted. Okay, so I keep y where it is. I'm going to subtract 2 on both sides. Now, did I divide by a negative? No, so sign does not change. Y stays there. Y is greater than 5 minus 2 gives me 3 plus x. And then just to make it look just like y equals mx plus b, I'm going to take an extra step to switch the x and the 3, and I'm done. Okay, in the next slide, you're going to see me take this a step further. But they ask you to spend some time doing this. Now, on this one, I have two choices. If I want to solve for y, I could either distribute the negative 4 into the parentheses and then work my problem, or I could divide both sides by negative 4. I'm actually going to divide both sides by negative 4 because that's really going to be easy. But have I done something to both sides? Have I divided or multiplied? I forgot to mention that fact. Divided or multiplied by a negative? I did. I'm dividing by negative, so I have to remember to switch the sign. Okay, now this cancels, and I get 2x plus 4y. And over here I get a positive 4. Now I still need to get y by itself. So I'm going to subtract the whole 2x, bring it over here. And I'm going to get 4y is greater than or equal to negative 2x plus 4. Then I'm going to divide by 4, and when I divide by 4 here, I need to divide every term by 4. It was a little different up here because it was multiplication, but here, because I have addition, I have to do it all the way across dividing by 4. My final inequality, this was actually a hard problem, and it may be exactly in your problem set, so you can try it. This answer will be y is greater than or equal to negative 2/4 becomes 1/2 x plus 1. Phew, that was a long one. Okay, this one here, I want to get y by itself. I really ideally would like to have y on the left. I think that will make my problems easier because I'm trying to get it in that y equals mx plus b format. So I'm actually going to bring my y over and then bring my x over. I'm going to add 15y to both sides. And I'm going to get 15y plus 5x is greater than 10 because that goes away. Now, I need to bring the 5x over. I still haven't divided or multiplied by a negative, so I'm still not changing the sign. I'm going to put my x term first. Now I'm going to divide by 15 all the way across. Every term needs to be divided by 15. So this gives me y. I did not divide by a negative. The sign stays the same. I get negative 5 over 15, same as negative 1/3 x, plus 10 over 15, which is 2/3. And I'm done. I may have pulled these right out of the lesson directly. If I did or I didn't, I tried to model it after ones that were close, if not. Okay, moving on. Now, that's only step 1. Now, graphing inequalities. Remember from jousting armadillos, solve and graph this. So when we were doing this in jousting armadillos, we solved it. This is a single variable, and I got negative 10. I divided by 2, did not divide by negative, so I don't switch the sign. X is less than negative 5. But then I had to graph it. So did you remember how to do this? Is it an open circle or a closed circle? Open circle. Open circle on 5. Nope, did that one wrong. What did I do wrong? Who knows? Yes, I didn't use negative 5. So it's an open circle on negative 5 because it does not include negative 5. It is just smaller than negative 5. So I put an open circle saying it's everything up to but not including, and I shade like so. Done. Now, what we do now is going to be very similar. Okay, let's look at this one. Very similar. I multiply both sides by -2. Multiplying by a negative. So my sign switches. I get 2x minus 8 is less than or equal to -10. Add 8, add 8. 2x is less than or equal to -2. Divide by 2. X is less than or equal to -1. Okay, open circle or closed circle. Well, this one includes -1, so it's a closed circle on -1. And x is smaller than or equal to, so it's going to go this direction. Okay, but that's from jousting armadillos. So now what are we doing? Now, whoa, changed focus there. Now we're going to graph two variable inequalities. Look, this is in y equals, not equals, but less than mx plus b. So all I need to know is what's my slope? 3/4. What's my y-intercept? -3. So I go to my y-axis, I find -3 and put a point. I do rise 3, run 4. So I rise 3, run 4, put a point. Rise 3, run 4, put a point. Okay, now normally what you do is just connect it and go on your way. But because this is y is less than the equation, I need to decide, okay, in jousting armadillos, I would have done an open circle, right? And I would have shaded this way. Now I am going to have shading, but my line is going to be a broken dotted line because it's saying it doesn't include this line, it's less than this line. Okay, then I have to shade. I'm either going to shade the top half of above the line or below the line. So if y is less than this line, I go to my y-axis. Here's where it crosses, the y-intercept. If y is less than, where are values less than y? If it's up here, the y values are greater. Down here, the y values are less. So this side is the side I'm going to shade. And I'm shading it with stripes. You can shade it with stripes, or you can actually shade it in. But that means that any ordered pair over here will satisfy this representation. Okay, well, let's pick something. Let's pick a point somewhere in my shaded region. How about right here? What are the coordinates of that point? 6. -2. So 6, -2 falls in this shaded region. So that should satisfy my equation. Let's see. My y, remember here, is -2. My x is 6. So I get -2 is less than 3/4. What's x? 6 minus 3. Well, 3/4 of 6. Oh boy. All right. Is 9/2. That's 4.5. Minus 3. What's 4.5 minus 3? 1.5. Is 1.5 bigger than -2, or is -2 smaller than 1.5? It is. So I know I got this right. All right. Let's try another one. Okay, here we go. Not in y equals mx plus b form. So force it. I'm going to add 3x to both sides. I get y. I don't need to change the sign. Is greater than or equal to, this is very messy, let's try again. Y is greater than or equal to 5x minus 4. No signs changed. What's my slope? 5. What's my y-intercept? -4. So, -4 point. Slope is 5. Rise is 5. Run is 1. So rise 5. Run 1. Point. Rise 5. Run 1. Point. Rise 5. No more room. Drop 5. Backwards 1. Okay. Now, I want to connect them. Would I do a dotted line? I don't know. Let's look. Y is greater than or equal to this line. So because it's greater than or equal to, in jousting armadillos, I would have done a solid line, a solid point. So I'm going to do a solid line in this case. And you're going to use a ruler because you're going to be able to get it better than I can. Now, if y is greater than or equal to this point, I've showed the equal part, but now I haven't showed the greater than part. So come to the y-intercept. Where are the y values greater? Above. So that means you're going to shade this part. And anything over here satisfies this equation, this inequality. Well, let's pick a point. Let's pick an easy point. How about this one? That's -1, 1. That should work. Okay, go back to my original equation. This is x, this is y. 1 minus 3 times -1 is greater than or equal to 2 times -1 minus 4. 1, this gives me plus 4. No, so excuse me, plus 3, because I multiply, is greater than or equal to -2 minus 4. This side gives me -6. This side gives me 4. Is 4 greater than or equal to -6? Indeed. Got it right. Slam dunk. Okay, good luck with this one.